Hi guys. Okay, so we're moving on to 2.7. 2.7 is applying the fundamental theorem of algebra. So I'm going to abbreviate that to FTA. When we're talking about the fundamental theorem of algebra, it is a theorem that is basically explaining how many zeros will be in a function. So previously in 2.6 and any time before that, we were finding real zeros. So we weren't finding all the zeros because there is some point in times where we have complex zeros, meaning that there is imaginary zeros within our answer. So what the fundamental theorem of algebra states in accordance to our zeros is that a polynomial will have exactly as many zeros as its highest exponent. I.e., there's going to be some real, some imaginary in certain circumstances. So in the following function, f of x equals x cubed plus fx squared, or 5x squared, plus 4x plus 20. We just want to know how many solutions, zeros, x-intercepts, and so on will there be. So we go to the highest exponent, which is 3. So there will be 3 zeros for this function, okay? Just as an example as to how we use that fundamental theorem of algebra. So each one of these problems are going to be pretty long because we have lots and lots of steps to them. This is going to be going off of how we found zeros in 2.6. So let's do the following example. Is this on the screen? Yeah. Find all zeros. So if you would go back and look at the wording in any of your homework for 2.6, you would see it says find the real zeros of the function. Now we're moving on to find all zeros of the function. And this function is f of x equals x to the 5th minus 4x to the 4th plus 4x cubed plus 10x squared minus 13x minus 14. Okay, so a really, really long function here. But that will be one of the things is that once we start moving toward finding real and imaginary, the functions get huge because we have an abundance of zeros. So the first thing is we will end up with 5 zeros. We know that because that's our highest exponent. So our goal here is to find all 5 of these. Again, some will be real, some will be imaginary. So we start this off like we would any problem in the past, where we do the rational zero test. Okay, so in this rational zero test, we have to take factors of our constant, so 14, over constants of our factor of our leading coefficient, which is 1. So all the factors of 14 would be plus or minus 1, 2, 7, and 14. I'm not missing any. And then factors of 1 is obviously just 1. So if we list out all possible, it is taking every number in our numerator over every number in our denominator. So basically just that top line in this case. So out of our possible zeros now, we want to find what are our real zeros. So we grab a calculator and we type this in to our y equals. One thing that some people had a question on in class that I want to show you is if you're trying to find how to put an X in, you use the button, and this is a little bit fuzzy, but it goes mode xt theta n. This button will get you an X to pop up in your y equals. So we go to y equals and we type in x to the 5th minus 4x. Oh, x to the fifth minus 4x to the fourth plus 4x to the third plus 10x squared minus 13x minus 14. And we graph it. So we are looking for places that we cross the x-axis or touch that x-axis. Okay, so if I drew you out what I'm seeing on my calculator right now, I am seeing the following thing. Something kind of like this. So here's where one new idea gets brought in that I need to teach you about. So when we cross our x-axis, like we do at this point, that represents 1, 0. When we touch the x-axis, this is called a multiplicity. What happens when we have a multiplicity is we actually count as 2 zeros. It's where we come up and we touch our x-axis and then we go back down. So 2 zeros actually are occurring at this point. It's because we're coming in from the left side and we hit, and we come back down from the right side and we're also hitting it right there. Okay, so when we're coming up, we hit, and then we go back down and we hit again. So 2 zeros are happening at this point, -1. When I would go to write these out, I would say I have, sorry, I'm just writing 2 zeros for you. I have 1 0 at -1 and a second 0 at -1 because again, 2 are happening at that point, 1 and 2, and then a third one at +2. And again, I'm only going through it, so I only have 1 0 happening there. 2 zeros when I touch, 1 0 when I go through. So these are the zeros that I'm physically seeing. So what do we do at that point? We have to go test them through synthetic division. So I'm going to erase what I have, at least I'm going to erase this graph, or go make it smaller somewhere so I have some room. And again, what I'm testing, I don't know how far you can see over, I'm going to write these over here. I am testing x equals -1, -1, and 2. Remember, when we test, we work our way from left to right. So we're going to start our furthest points over and work our way right. So my first synthetic division will be with, that's a pretty long synthetic division, will be with -1. My second one will be with -1. You can't see the bottom of that. And my third one will be with 2. Okay? Where do I get, and I need to give myself more room actually, because these are going to be some pretty long ones. We go test to see, do we need a 0 placeholder? Again, we would need a 0 placeholder if we skipped an exponent or skipped a degree. You have to go in descending order. So I go from 5 to 4 to 3 to 2, 1, and then nothing. So I've not skipped anything, so I don't need any 0 placeholders. So I go and I take all of my coefficients, including the last constant, put them up top, including their signs. So 1, -4, 4, 10, -13, -14. Again, you extend the synthetic division for however many numbers you need to have it be. The first thing we always do is drop that first number down, whatever number that may be. First number comes down. So 1 times -1 is -1. We now add those two numbers up to get -5. -5 times -1, +5 brings me 9. 9 times -1, -9, add those up, we get 1. 1 times -1, -1, add those up, -14. Negative times negative makes a positive 14, we get 0. Again, I need to get a 0 remainder if this truly is a 0. 0 remainder tells me, yep, -1 was a 0, go ahead and keep going. If you don't get a 0 remainder here, you need to go back and check your work. There is a lot going on here for synthetic division. It was very possible that you made a mistake, especially when we're talking about negatives. We make a lot of mistakes when we're multiplying two negatives together, multiplying a negative and a positive together. We also make a lot of mistakes when we're adding negatives and positives. Any of those circumstances, you could have made a mistake on. My biggest suggestion would be to go back through and check your work on this. So after we get this zero remainder, we keep going, but we don't start over. We bring down our last numbers to our next synthetic division. This is why if you do not have a zero remainder here, don't keep going because you need to go figure out where your mistakes were. If you just keep going, you're just going on another path of wrongness, like you're not getting anywhere. Okay, so drop your first term down, 1 times -1, -1, -1 plus -5, -6. -6 times -1, +6 brings me 15. -1 times -1 times +15 is -15. Add those up, we get -14. Negative times negative makes a +14, and I get 0 as a remainder. Okay, I'm going through these a little bit quickly because the synthetic division is kind of the old thing to us now, right? We've done synthetic division a lot, so we should have the hang of that by now. Again, 0 remainder tells me my second -1 was in fact a 0, so I can go ahead and keep going now. We open up my third and last synthetic division for the 0, 2 that I want to test. Again, we don't start over, we go ahead and we keep going using our last numbers here. So we fill up our top of our synthetic division with -1, -6, 15, and -14. Okay, again, it's imperative that you do have a 0 remainder. Don't keep going unless you have those. Do our synthetic division, drop the 1 down. 2 times 1 is 2. Add these up to get -4. 4, times +2 is -8. When we're adding 15 and -8, we're going to end up with a +7 here, okay? 2 times 7 is going to be a +14 to get us to be 0 remainder. Again, when we're getting a 0 remainder, that's exactly what we needed to prove that 2 was in fact 0. So here's where we're at. How many zeros did we need? 5. How many zeros do we have? 3. So we're not done yet, okay? I like to make this running tally of our zeros. So we've so far proven that we have 3 zeros. We need to add 2 to this list to be done. So let's go back to where we finished off. This last term represents your remainder, your constant, your x, and your x squared. So currently I've factored out the solutions of -1, -1, and 2. I want to reiterate something to you though. These represented as factors would be the opposite, right? If I have a -1 as a solution, it was a +1 factor. -1 solution, +1 factor. +2 solution, -2 factor. So I've currently factored out these 3 things from my original equation. Okay, factored these out from the original equation. What's right here is what's left. So this represents x squared minus 4x plus 7. Okay. So I've found 3 zeros from these. My last 2 are going to come from this last trinomial. Okay, again, I found zeros from these 3. Now I need to find zeros from this last one. So when we're factoring a trinomial with an a value of 1 or a leading coefficient of 1, we like to say, find 2 numbers that multiply to 7 and add to -4. I'm hoping you're quickly realizing that that's not possible. When it's not possible, our fallback option is we have to do quad form. So I want to remind you, there are going to be times where this can be factored, not quite factored. I'm sorry, that's the wrong way of putting it. Where this can be solved for without doing quad form. if I only had an x squared and a constant, so no middle term, you could just set equal to 0 and solve. In this case, I'm gonna have to do quad form. Again, this is because I have a quadratic with a single x term. So I have to do quad form. This would be my a equals 1, b equals -4, and c equals 7. I'm gonna try to get it squeezed into this last little space over here. Actually, I'm gonna go ahead and erase this because we don't need this quite anymore. Okay, so quad form is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So we need to plug in what we know for a, b, and c. We have a -4 plus or minus square root -4 quantity squared minus 4 times 1 times 7 all over 2 times 1. Okay, let's keep solving this down. Negative makes a positive, so we have +4 plus or minus -4 squared, which is 16, minus -4 times 1, which is -4. So -4 times 7, that's -28, all over 2 times 1, which is simply just 2. So we just have to kind of keep simplifying here. The next thing that we're going to want to do is simplify inside the square root. So I'm going to jump this up here so you can keep seeing it. But we still have x equals +4 plus or minus what needs to go on the inside of the square root. We have 16 minus 28. That is going to be -12 all over 2. So here's where the imaginary portion comes in. We were waiting for it, we knew it had to happen. It's because we have a negative inside the square root. So x equals 4 plus or minus I positive root 12, right? Whenever we have a negative inside of a square root, we bring out that negative to make the inside positive. That negative shows up in the form of an I in the outside, all over 2. So we could break this up one more step, right? Take this fraction over this fraction to get x equals 4 over 2 plus or minus I root 12 over 2. Giving us a final x value of 2 plus or minus I root 12 over 2. You could simplify this. If you did the honors topics, you'd be able to simplify that radical. I'm okay with you not doing it though. Okay, what does this mean for us though? 2 zeros come out of this. Okay, I get to add on to my zeros here. The 2 zeros I get to add on is 2 plus I root 12 over 2. And, right, that's a whole 0, 2 minus I root 12 all over 2. Okay, let me erase this top term, or this top line, so you can kind of see those better. These 5 things are the zeros. Okay, all 5 of those. 1, 2, 3, 4, 5. It's important to remember 2 zeros come out of that plus or minus. Okay, I want to do one more. It's going to be a shorter one. These problems in general are just longer. It's impossible to get away from that fact. They're just always going to be longer problems because of how many steps they take. So the last one I would like to do with you is x cubed, f of x equals x cubed plus 5x squared plus 4x plus 20. Oh, sorry, you can't see that. Okay, there we go. Okay, so again, if you feel comfortable doing so, I would try this on your own. Come back, watch this part of the video, see what you did wrong, right or wrong. So if I were you, I'd pause it, or try to do this myself, tune back in and try to see if you're on the right track. Rational zero test first. Factors of 20, plus or minus 1, 2, 4, 5, 10, 20. Factors of the first term is, or leading coefficient is just 1. So it's basically going to be this whole, a shortcut for that. If I know I'm just dividing by 1, it's basically just what my numerator was going to be. Okay, so now you go plug this into your calculator. So into your y equals, we go ahead and put x to the third plus 5x squared plus 4x plus 20. We graph it. We want to see, where do I see zeros happening? Okay, let's graph it out. At -5, we go shoot, and we keep going up and we never come back down. Okay, so where do I physically see a 0 at? Where I cross the x-axis is where I see a 0. I'm not touching it, I'm crossing it. So at -5, I see 1, 0. So there's a possibility that it only crosses the x-axis once. There's a possibility it does not cross the x-axis at all. In this case, I do cross it once, so I can go ahead and do synthetic division with this -5. I test to see, do I have any 0 placeholders needed? 3, 2, 1, none, so I don't need any. Go ahead and fill in your 1, 5, 4, 20. Drop the first term down. 1 times -5, -5. Add those up, 0. 0 times -5, 0. Add those, 4. 4 times -5, -20. We get a remainder of 0. So 1, -5 is in fact a 0, but let's check. My highest degree is a 3. So I need 3 zeros total. How am I going to find the rest of these, right? This is 3 zeros. I need to continue finding 2 more. I found 1, I need 2 more. So we say, okay, I've factored out an x plus 5 so far. Okay, why x plus 5? I have an x minus, or x equals -5. We take the opposite, x plus 5 is what we factored out. Down here is what we have left over. So remainder, constant, x squared. So I have a 1x squared. I have no actual x value, so I don't write it. And then I have a plus 4. So my 0 already came out of this. My second 0 needs to come from, my second 2 need to come from this. So if we could, we'd love to be able to factor this. You need to find 2 terms that multiply to 4 and add to 0, specifically positive 4. So factors of 4 are 1 and 4, 2 and 2. If this was a -4, it would work, right? It'd be difference of squares. I could take -2 plus positive 2, get 0. But -2 times positive 2 equals -4, not positive 4. So factoring is not going to work here. The good thing is I don't need to do quad form because I have no middle single x term. I can set this equal to 0 and solve. And I'm going to raise this up because you can't see that at all. X squared plus 4 equals 0. You can't see that any better, sorry. Subtract 4 to get x squared equals -4. Now we have to take the square root of both sides to get x equals, first, when you take the square root, you have to do plus or minus, okay? Second, we have a negative square root. So we throw an I out front and make the inside positive. So now we have x equals plus or minus I square root 4. We know the square root of 4 is 2. So x equals plus or minus 2i. our last two zeros, positive 2i, negative 2i. There are our three. So you've seen the two different styles of finding zeros, especially the imaginary portion. The first one, we ended up having to do quad form. We had an enormous amount of zeros. We had 5 total zeros in that function. And then 2 of them are going to not generally, always an even number will come from your imaginary. So if you have an odd number for your highest degree, you're going to have that even number no matter what for your imaginary. So you've seen where we can just solve to find our 2 imaginary, and then you've also seen how to do quad form to find those last couple imaginary. So this is the end of this chapter. This is as far as we're going to go into this. If you're looking for the honors topics, they're on YouTube. Go ahead and look those up. I have the suggested problems I would try if I were you. It's 2.8 and long division, basically, for the honors topics. So if you're interested in doing those, go ahead and try those. We're going to spend a couple days on this chapter, in this section in class. So don't feel like you have to rush through this all in a day. Digest it once, ask some questions, come back and we'll do some homework on it on Monday. It will be our class time that we're doing that. So we will be doing a test either Thursday or Friday of next week. So just be prepared for that. Okay, let me know if you have any questions.